Hello, good evening and welcome everyone to the webinar organized by the Library and Publication Committee of IESL. Today our topic is Organic Agriculture, Challenges and Possibilities. First of all, I just want to tell that this will be purely a knowledge sharing session on organic farming. Therefore, we request all of you to open your mind and see all future prospects with regard to organic farming. We will also try to dig information in existing knowledge in the world. So today our resource persons are, we have invited Professor Priyanta Yapa, Faculty of Agricultural Science, Sabaragamuwa University. Professor Saman Dharmakeerthi, Faculty of Agriculture, University of Peradeniya. Professor Wun Jern, School of Civil Engineering, Nanyang University, Singapore. Professor L.M. Abeywickrama, Faculty of Agriculture, University of Ruhuna. Before coming to the discussion, I would like to invite Professor Ranjit Disanayake, the Chairman of Library and Publication Committee, to deliver the opening remarks. Sir, over to you.
Thank you, Tilak. Good evening, everybody. Welcome to our webinar series. And I especially would like to welcome Professor Yapa from the Sabaragamuwa University and Professor Wun Jern from Singapore, Professor Dharmakeerthi from University of Peradeniya, Professor Abeywickrama from University of Ruhuna, and all the invitees, President of IESL, Vice Presidents, Council members of IESL, members of IESL, ladies and gentlemen. It is again a great pleasure for me to welcome to this seminar, the webinar series conducted by Library and Publication Committee. We, Library and Publication Committee, try our best to bring the latest discussion of the country to the kind of panel discussion. Recently, we had a discussion on the burning ship, and today we are talking about the organic agriculture and the challenges and possibilities. When it comes to the today topics, as you know that the government has decided to go for the organic agriculture. Then we being professionals of this country, it is our duty always to see the challenges and opportunities, and especially we being engineers, why we decided to have this kind of webinar series today, because we as engineers must know where we can play a role being engineers. There may be a lot of requirement when it comes to the implementation, agriculture farming and machineries and so many things, so that we should have understand the real challenges and opportunities. Then only we as a IESL we can get ready for this one. That is the reason why we have, as a Tilak correctly mentioned, we need to have the knowledge sharing session today. So this will open up a lot of opportunities our engineers as well as other professionals. Therefore, not taking much time, I would like to invite Engineer Tilak Jayatunga to continue the panel discussion with today. I wish you all a wonderful webinar series today. Thank you.
Thank you, sir. We have, of course, invited 4 panel members today representing various universities. Our first panel member is Professor Priyanta Yapa. He is the committee member of Presidential Task Force. Unfortunately, I cannot see him right now at this stage. I hope he will join in a while. Until such time, I will invite Professor Dharmakeerthi to start the conversation so that we will be able to move forward. Professor, good evening, Professor Saman Dharmakeerthi. Professor, you are there?
Thank you and good evening. You can hear me?
Yes,
and
Professor.
You can see right.
Yes, Professor. So now, as Professor Ranjit Dissanayake mentioned, the government has decided to move towards organic agriculture. According to you, what are the major challenges we may face when moving towards organic farming with respect to current soil condition and maybe various other dynamics are there? So how do you start this discussion, conversation, giving challenges, stating challenges about organic farming? Yes, Professor.
Yeah. Thank you, Tilak Jayatunga, and thank you, IESL, for. Can you all hear me?
Yes,
Properly?
Professor. We can hear you very well. You can start the conversation.
Thank you, IESL, for inviting me for this important topic to discuss and share some of my experiences with you all. And it is very important and timely event that you organized. And I must thank the organizers for organizing this knowledge sharing event. And I must start with the brief introduction about this decision. And I think when you go through the stars of prosperity of the present government, it says categorically that there's going to be a revolution in fertilizer use in the country. And gradually they planned to go into a shift into 100% organic agriculture. And the thinking behind that was that the health of the people has been affected because of the chemical fertilizers used. And when it comes to agrochemicals, we talk about two things, about pesticides as well as chemical fertilizers. And the banning of chemical fertilizers also has been sort of put into the same basket of chemicals that will destroy the plant. And that is one of the major misconceptions that I see in my mind. And most of these issues related to kidney disease as well as cancers have been due to this chemical fertilizer, which I think the recent publications are emerging that it is not the case often. And there are, if somebody wants, we can discuss it more. And with that remark, I will go into the questions that I posed on me. What are the current situation in the soil after sort of using chemical fertilizers for 60 years? And then what are the challenges as I can see it at the moment when we are moving towards organic agriculture? I think there's again a misconception. I can say that I think we are not sort of aiming towards organic certified agriculture. I think in the country, what we are trying to do is to replace plant nutrients from organic sources. So I should also mention that. And if I may share some of my slides, do I have the privilege to share the screen?
Yes, you have. You can.
So you asked the question, what is the situation in the current conditions in the soil? Because all these chemical fertilizers have been applied onto the soil. So what is the situation? Can there pose a challenge to us when we try to understand the soil resource in Sri Lanka? I think some of the properties that I'm going to list here today as challenges when we are managing plant nutrients using organic sources are not related to chemical fertilizers. They are related to inherent soil properties in a tropical country like Sri Lanka. And one of the biggest thing that we need to deal with soil resources is the variability. And you can see there are about 120 different soil series in Sri Lanka. And on top of that, application of different levels of fertilizers and different crops have created a huge variability within Sri Lanka. So managing this variability so that we produce the optimum crop produce is a big challenge. And then our soils are mainly sandy and very low clay content, and even the clay content is not the quality clay content that we see in the other parts of the world. We have hydroxy and aluminum, iron and aluminum hydroxides and oxyhydroxides, which has very low cation exchange capacities. And about 60% of our lands are not eroded now. So you can see in many places, the landscape has been eroded. Is it due to chemical fertilizers? No, it is due to poor soil conservation practices that has been adopted in agricultural lands. And because of these things, our soil organic matter content has been depleted. And as you can see, if I minimize this one, this is the type of soil we have. You can see that it is not fertile. One of the main reasons is the low organic matter content, and we need to transform our soils into this type of beautiful land, beautiful soils, which we don't have in many. So this is one of the major challenges that we need to address, where we have failed to address how to increase soil organic matter content in Sri Lankan soils. And because of that, there are low plant available nutrients and poor nutrient holding capacities in the soil. So whatever the fertilizers or nutrients that we apply, they just wash out and sort of accumulate in water bodies. And very low water holding capacity, therefore we cannot resist in the dry period because of these reasons. So these are the type of things, but in addition, man-made things, because of high application of organic fertilizers, poultry litter for mainly in the Nuwara region, in addition to our chemical fertilizers, and we have accumulated phosphorus conditions, and which sort of degraded our soils and therefore our surface water bodies as well. So the next question that you ask is, can we supply nutrients demand for present day cash crops through 100% organic fertilizer? Before I answer this, I think this is the audience where we have a group of people who have a very good understanding on the science. So I should emphasize some basic principles of soil plant nutrient management. So when we talk about soil fertility, we talk about the capacity of a soil to provide plant nutrients. So that is the soil fertility. And there are so many other factors that is coming in as well, but that plant nutrient has to be provided in quantities that is required for the plants, in forms that are required or can be absorbed by plants, and ratios that are optimal for plant growth, right? So these three conditions has to be fulfilled. Now, if you add urea, for example, plant will not take up it as urea. If you add organic matter, plant will not take up nitrogen as organic matter nitrogen. It first has to convert it into plant absorbable form, and then only a plant will take up. And then the ratios is important, because if one element is less, and it will affect the uptake of other elements and the growth of the plants, and what we call nutrient deficiencies. And then there's another big principle. I think we can apply it into not only for plant nutrient, but it can apply for anywhere in our society. That is the Liebig's law of minimum, a German chemist, and who often considered as the father of agricultural chemistry in the Western world. He come up with this idea that plant will not grow if one growth factor is limiting. Even though you apply all other growth factors, if one is deficient, then the plant growth stops, right? So those principles are important to understand whether we can supply nutrients demand of a
Professor, if I ask you one question, because I have read certain things regarding dead soil and living soil, there are two ideas come up with, because of modern farming, there is a dead soil happened here, like, existed here. And then those days, since we had organic farming, we had a living soil there, and then any kind of crop can be grown easily. Now, actually, that we can experience in our day-to-day, our home garden also. If we are trying to grow one piece of this something, it is very difficult to grow with usual practices. So how do you explain this situation? Because many of people, they complain to this synthetic or this artificial this thing, because of that this dead soil condition happen. So how do you explain this scenario?
Yeah, very important question, and I'm glad that you raised that question. Now people talk about dead soil and living soils, and they talk about there are earthworms and there are no earthworms because of the chemical fertilizer application.
Yes. I mean, we can really like experience it in day-to-day life, our normal life, now, although we are not farmers.
Very correct. So you will experience certain conditions, but you need to understand that it has to be related to the cause that you are blaming for, right? Now, generally for living beings in those creatures who live underneath, they need organic matter to get energy. Particularly, it is a food of a web, where the lowest one is microorganisms, and then when you come, you have higher order organisms. If the lower order organisms are not fed enough, then the higher order organisms also will be sort of with time deteriorate or vanish. Now, what is the food for microorganisms? The food for microorganisms is organic matter. Organic matter gives the microorganisms carbon and energy. And I remember I said that because of 60 years of cultivation and because the rate of faster decomposition and erosion, our soils are not rich in organic matter, and therefore they cannot support a good microbial community, which affects other strata of organisms in the soil, right? Whether the microorganisms were affected solely because of the chemical fertilizer application, I wouldn't believe, because it is mainly the carbon content in the soil that is why we always, as plant nutrients, we always say apply organic matter to our soils. We need a living soil. Why we need a living soil? We need living microorganisms to first place. If we can nurture the microorganisms only, then we can have a food web that is growing in the higher order organisms. I hope that I explained my question.
Yes.
But because of the chemical fertilizer subsidy, chemical fertilizer subsidy that has been existed during so many decades, we fail to introduce or to push farmers to apply organic fertilizers.
Okay, I got your point, and right. We are moving to the next panel member. Actually, as I mentioned earlier, I have invited Professor Yapa. Actually, I think Chamila, we cannot see him as of now, right? So let's talk to then Professor Ang from Singapore. Actually, Professor, from his background, he is a civil engineer from Lankan University, but he has done a lot of research with regard to the subject, and he is very famous on doing applied research with regard to many areas. So he's a famous researcher in the area. So we wanted to talk to him with regard to international experience and international trend. So good evening, Professor, and thank you very much joining with us from Singapore. Professor Ang?
Good evening.
Hello, how are you?
Fine. Yes. Can you see me?
Yeah. Yes, Professor. A little bit. If you can center your screen to the, you can face to the screen.
Right. Okay. Hope you can see me better now.
Yeah. Okay. Now, I just want to ask from you, how do you explain us this international trend? Because we have seen many countries are talking about this organic agriculture right now. And could you explain us the preparedness of international community through innovations and R&D activities on reaching organic solutions? How do you explain this to Professor?
Thank you, Mr. Tilaka. Can I ask for your side to share the screen, please? Right, thank you.
Yeah.
Now, I would just want to quickly qualify myself, Mr. Tilaka, and of course, all the participants who are on the discussion at the moment. I'm not an agricultural engineer. As the chairman said, I am a civil engineer who has seriously lost his way during my career. So I wandered into microbiology and molecular biology. And because of that, I then developed an interest in the ecology, the microbial ecology in soils. So that is how I ended up in this area of working with biofertilizers and so on. Now, I would just like to ask the participants to look at the screen at the moment, because the question that was posed to me is, what is happening internationally? Are we aware of the kind of situations that farmers are facing when they practice what I would consider, or what I would call, perhaps erroneously, traditional agriculture? And in my mind, traditional agriculture would be something that one would do with chemical pesticides and chemical fertilizers. And you can see on the outer ring the sorts of situations that are now being observed. So there is increasing observation of the deterioration in the quality of agri-soils, much like what the previous resource person was saying. And I think even the more worrying trend is that even as we attempt to address the declining yields of the crops that we plant by increasing the amounts of chemical fertilizers and chemical pesticides, we may not necessarily see corresponding increases in yields. And there is certainly, at least in my part of the world, there is certainly an increasing incidence of plant diseases that have been observed. Can I ask for the next slide, please? Right, I want to just illustrate what I've just said with something that I'm familiar with, but perhaps not so common in the Sri Lankan context. In my part of the world, we do work on the oil palm. And this is because it is a major cash crop in many countries in ASEAN. So for example, Indonesia and Malaysia are leading palm oil exporters. So the well-being of the oil palm tree is very important to the agri-sector in ASEAN. Now, we have noticed over the years that there has been an increase in the incidence of a fungal infection. So this would be the fungus marked with a cross, Gardnerella boudinense. For interest's sake, Gardnerella comes from a rather large family, and not all of this type of fungus is bad. So for example, the one with the green thick, Gardnerella lucidum, is good. In fact, the Chinese use it as a herb in herbal medicine. But the boudinense variety is not good because it affects the tree trunks of the oil palm, and it causes structural damage. Sorry, I'm talking like a civil engineer now, but it causes structural damage, and over time the tree falls over. Now, when we first started looking at this, we noticed that, of course, the farmers were applying pesticides, fungicides actually, to address the disease. So I call it a disease. And you know, there are times when there was some success, but there are also times when it didn't seem to work. So we look at the soil, and we noticed that there is I would call it a peculiarity, and that is the relative absence of earthworms, but the increase in the numbers of nematodes. So nematodes look like little baby earthworms, but they're not earthworms. They are different. And we kind of guess that the nematodes are somehow carrying the fungi to the oil palm and causing the disease to spread. Now, this has given rise to the argument that the previous speaker talked about. Why is it that the nematodes have sort of superseded the occurrence of the earthworms? And one of the issues that we thought could be contributing to this would be a loss in the balance of C and PK. I think very often we talk of NPK. We forget that there's actually a need for the C. And it is placed right in front of the C. It creates conditions in the soil that, for example, would help to improve the soil structure, and that goes on to help retention of water, retention of fertilizers, and of course also allow the microecology to survive in a balanced manner. So what I'm trying to say is that when we lose that balance because there is a loss in one of the nutrients, and in fact I would call the C as one of the important nutrients, then we have this proliferation of the nematodes, and that goes on to the spread of the fungal disease. So what are we doing now in this part of the world? So we are looking at R&D that allows us to not only rebalance the C part of the CNPK equation, but also to look at the kind of microbes that could be helpful to the soil conditions that we are seeing at the plantations. Now, this is where a lot of the research is going on, because we know that the microbes, bacteria, fungi, good fungi, for example, they produce at least 3 things that would be useful to the farmers. Number one, the enzymes. So these would help to break down the various complicated compounds that are in the soil to simpler compounds that are usable by the trees. Then there would be the phytohormones, and these are used to promote, for example, plant growth, flowering, fruiting, and so on. And the third category would be the Phyto Antibiotics. I call it antibiotics. There are proper names for it. So we use this to control the pathogens that may be adversely affecting the crops that we are trying to promote. So these are very briefly some of the things that we are doing. And of course, when we look at the microbes and their behavior and the metabolites that they generate, then ultimately we also need to be able to scale. Because if we can't scale the production of these items, then it will be hard to bring these technologies out into the field so that the farmers can benefit from the R&D that is being done. So a lot of the work has also gone into scaling the production facilities that are needed. Now, I must emphasize that when we move into this stage of biofertilizers, we are actually quite a distance away from what our sort of, our colleagues who may have an interest in gardening and making a compost pile in a corner of their gardens. This is very far from that. This is industrial scale production of biofertilizers. And when we talk about industrial scale production of biofertilizers, there are a number of components within this one word, biofertilizer. There are the bioactives, which would be the microbes and their metabolites. Then there would be the carbon, which would be something that is also used to carry these microbes and their metabolites to the soil. And of course, there is also the soil conditioner, which could also be contributing the carbon, and it could be something like biochar, for example. So that helps to improve the fabric of the soil so that the microbes can survive better. And when the microbes survive better, the bigger animals like worms survive better, and then the plants in turn survive better. Thank you. I hope I've been clear.
Yes, yes, Professor. Thank you very much for giving very good explanation. I'm taking this opportunity now because Professor Priyantha Yapa, who's supposed to start this conversation, has joined with us right now. So because he is representing the presidential task force, which is set up especially for this organic farming. Good evening, Professor Priyantha Yapa.
Good evening.
Good evening, Professor. So I just want to ask the same question. I mean, I will ask again because how do you, Sri Lanka is moving towards organic agriculture now. How do you explain the possibility of this trend considering available resources and also technical know-how? By now you have a good assessment, we believe. How do you explain this situation to us?
So, excuse me, did you ask from me?
Hello. Yes,
Okay, yeah, okay. So the assessment actually, so the thing is, this is a kind of a sudden conversion.
Okay.
So yeah, so that is, I think that is one of the reasons why most of the scientists, including me, actually, have started struggling, and some have many speculations about this, the success of this process. Yes, but anyway, for some reasons, so government actually government has taken decision for some reasons. So we don't know the full reasons. But anyway, now as scientists, what we are trying to do is actually to find actually the methods and the ways to go ahead with this. So it doesn't mean that, you know, that it doesn't mean that we can't, but there are methods and the techniques and the strategies that we have to use. So we are going to use all the possible strategies to get into the track. So actually, with this sudden conversion, so what most of us expect is the yield drop. So to avoid the yield drop, so what we have planned is actually, so our estimations indicate that we have actually, so we will face some problems with getting the nitrogen requirement for the plant properly. So therefore, at this time, so we are thinking about so importing this nitrogen requirement anyway. So if there is any need, so this is our strategy. And also, so we have the ministry has started a special program to engage with the farmers, to train them to produce their own fertilizers, so to produce the fertilizers for their own use. So with the technology given by the Department of Agriculture. So the Department of Agriculture has started working hard to actually get this technology at farmers level, to transfer this technology at farmers level through the agrarian development centers. So actually, so this is a kind of a new things to Sri Lanka, because most of our scientists, actually average scientists, are not used to this organic program. So the organic agriculture, the way of producing food using organic inputs only. So therefore, actually, yeah, there will be some issues. There will be some issues, but we are trying our best to solve all these problems. But anyway, we know that anyway, so we will have to feed the people. We will have to feed the people. So we'll have to maintain the food security in the country. So at the same time, so we'll have to protect the soil resource, the limited soil resource, limited land areas that we have to produce food. So there are, the many issues actually attached to this. But I think the Sri Lanka, so the government, actually through the ministries, Ministry of Agriculture and Ministry of Plantation, so we'll do everything possible to go ahead with this program. So only problem that we will have is with this within this very short period of time, maybe, yeah, it is actually, we have to, the task is actually, it is a very big challenge. The task is to fulfill the requirement of the demand coming from the farmers for mainly nitrogen fertilizer.
Professor Yapa?
Yeah, yes.
Yes, yes.
Yeah.
Now, you are talking about challenges and, of course, existing resources and existing knowledge.
Yeah.
So now, many people say that this organic farming will lead to smaller yield, and then, let's say, more workers will require, and then some people believe it is expensive. So do we have a quantification on this, like, because we are right now in terms of yield, and then in terms of workers or technology, in terms of cost, if, what we have to incur. So have we estimated right now all these things?
Okay, so then, first we will take the yield,
yes,
or the productivity. Okay, so that is the amount that we produce per unit area, per unit period of time. So let's say in short, we'll say yield. So of course, actually, so the yield has nothing to do with whether it is organic or chemical. So actually, it is up to yield will be decided by the technology that we are going to use. So even if we use wrong technology, so let's say that not enough fertilizer, so imbalanced fertilizer mixture, even through this the chemical farming technology, so we will not achieve the proper yield. And there are many other factors affecting yields, for example, the water shortage, pest and disease, many things. So therefore, the yield actually has nothing to do with whether it is organic or chemical. It is actually, yield is something, yield has links with the technology that we use. So for example, let's say that if we use wrong organic farming technology, so we'll end up with massive yield losses. So therefore, it is something to do with the technology that we use. So when it comes to the cost, cost is actually, people in Sri Lanka may feel that the chemical farming is very cheap. So the chemical farming, the cost is very low. So actually, yes, cost actually remain low because of this subsidy. So for example, so the government actually bear a massive subsidy for this fertilizer program. So for example, let's say that government purchase triple superphosphate for 50 kilo bag, 3,750 rupees. And then the government give that to the farmers for 1,500 rupees. And urea, so government actually purchase 50 kilo bag for 2,800 rupees, and so government sell it for 1,500 rupees. So therefore, the subsidy actually has reduced the cost. So it is actually not the cost attached to the chemical farming is not actually the true cost. So it is actually the fake cost because of the subsidy. So so we learned that government has spent 65 billion Sri Lankan rupees for the subsidy alone in 2020. So the cost is actually based, cost actually has links with subsidy, because we have never subsidized organic inputs. So therefore, the farmers may compare that actually the chemical farming is cheaper. So the other point that you raised is...
Professor Yapa, if I disturb you a little bit, if you allow me, because someone has sent me a message saying that this urea has about 46% nitrogen, and then organic may have 3 to 5%. He has quantified. So what is the unit cost of nitrogen from two sources? This is important to the farmers. Like, you know, they compare nitrogen percentage in both cases.
Yes. When we compare, of course, we know that urea has 46% nitrogen. Yes, but the thing is, at the same time, you have to understand that use efficiency of urea actually remains less than 20%. So when it comes to, I learned from the tea sector. So in tea sector, for example, the use efficiency of urea is actually remains around 18%. So it means that, you know, even though the urea has that much of nitrogen, so actually we cannot actually get that much because of that low efficiency. So when it comes to, when you try to actually figure out the unit cost, so we have to calculate all these things. So the use efficiency, and also we have to, when we calculate the cost for urea, so we should remove the subsidy. So we have to use the actual cost. So not 1,500, it should be 2,800 urea, the price. And also we have to, actually take into account the contribution of natural microbes to produce nitrogen. For example, so if you have ideal organic system, so the contribution from natural microbes in an ideal organic system to supply nitrogen is about, it may go up to, under ideal condition, it may go up to nearly, sometimes up to about 40%. So the 40% requirement will be from natural microbes. So if we apply actually synthetic chemicals into the soil, so that system get disturbed. So therefore, when we actually try to calculate the unit cost, we have to take everything. So the other main problem is that urea, we always import urea. So that is another issue. So when we have to actually depend on imported urea. So that is, there is a risk factor as well. So we know that I think the urea export mainly is with Russia. So the 14% of the urea export in the world is from Russia. So one country. So if there is, therefore there is a risk as well, because so we have to depend on external sources for urea. So therefore, so we have to take everything into consideration. I mean,
and Professor, another person is asking a very simple question. He is asking about rainforest. How does it sustain without chemicals? Can we replicate such soils for farmers?
The thing is, we have to understand this. Actually, from a rainforest, we don't remove anything. So in an agro ecosystem, even in a forest garden, we remove something from it as the crop yield. So therefore, with the crop yield, we remove actually the fraction of nutrients from the system. So therefore, we cannot expect the 100% recycling in an agro ecosystem. So maybe one of the best sustainable agro ecosystem is Mayan forest garden or Candian forest garden. But even in Candian forest gardens, we have to actually use external inputs, because we remove some amount of nutrient with the crop yield. That is the issue. So that is the difference. In a natural forest, of course, we can expect 100% recycling. So therefore, definitely we will have to think about that. At least we will have to think about giving the amount of nutrient back to the system, since we remove part of that as the crop yield.
Yes. Thank you very much, Professor Yapa, because we have another round. We will answer to the other questions later. So now I'm going to Professor L.M. Abeywickrama. He's very famous on social and economic analysis of this subject. Professor, are you there? Good evening,
Okay,
Professor.
yes, I am here. Can you hear me?
Yes, yes, Professor. If you can a little bit center your face to the screen, because it is you have to turn your computer. That now it's okay. Yeah, yeah. What kind of economic impact, or rather economic challenges, do you expect from these situations, especially for rural farming communities? So would you able to analyze, because as of if you can explain us the situation right now and in long term and short term, medium term, how you can categorize this thing?
Okay, thank you very much. Actually, thank you for organizing this kind of forum and also that inviting me just to give some ideas. And also that can I share my particular what you can say slide? Means there are can I?
Yes.
Yeah. Okay. Right.
You can share now.
Okay. Right. Okay, now actually just starting a very few, actually that both presentations, actually both sessions, I will just combine together the presentation. But anyway, now actually that what I am going to tell, actually now we have come a long journey in agriculture, because actually theoretically we have different systems. Actually at the beginning, because land is not a limited factor, that now at those period actually we have forest fallow, that kind of agriculture system, just cutting the very old forest, that what I normally single say nowadays, that kind of very fertile soil we have. We could produce our food without having very small, actually very laborious activities. Just very simply we can produce our requirement, because population is less, sufficient number of lands over there, that is called forest fallow. Later on, while the population is growing, what happened actually that we cannot keep that land for a long period, about 25 years, to grow as a big forest. And now actually later on we came to that bush fallow, that means somewhat grown forest but not fully grown forest. That is later on. That gradually actually we have changed our system. Now we have come to that multiple cropping system. Actually per year we are cultivating several seasons. We are removing many vegetative parts from the soil. With that, we are removing a lot of nutrients from the soil, nitrogen, phosphorus, potassium, and many other nutrients. Now, actually, that problem is actually now we need more crop from the land unit, because we have limited land area. We cannot cut the forest. We cannot encroach the forest. Now we have to produce more for the more population with the small land area. That is the challenge we have now after coming to very long period. And now actually for this purpose, actually to produce this very large amount of crop for a large amount of people with a small or declining amount of land. Now a lot of people, actually in Sri Lankan situation, I'm not going to talk about the world situation, also a lot of stories are there. Now in Sri Lanka also we have the Department of Agriculture, more than 100 years they are operating, Department of Export Agriculture, TRI, VRI. And here actually in these institutions, there are a lot of experts. Now actually nowadays, actually very recently we submitted a document to the Presidential Task Force and President, just actually giving all the information. That is so. This one also coming from that document. Actually, we just calculated about 1,000 experts. Many of the people, many people are having their degrees in other countries, PhDs and MPhils and different degrees. But all are experts. They are working actually. In the past also, there are a lot of people. That is the way we have come to this point. Now actually that what is happening today? Actually now we are going to deal with very big sector. Now actually 40% of the land area in the country, and also 80% of the water resources used by the agriculture sector. 50% are small scale, that means normally less than 0.1 acre. Normally 90% of the agriculture communities less than 2 hectares. about 50% are less than 0.1 means about quarter of an acre. And also 80% of the food production coming from this small holding sector. And 70% of the people directly or indirectly involved in agriculture. Although you are a teacher, maybe some other kind of job, many people are doing partly or particular agriculture activities for additional income. That is also there. And with all these things, actually, we are importing around 2.2 billion per year for food. And also, we are giving subsidized fertilizer, as Professor Priyantha mentioned, and efficiency also very less. Fertilizer use efficiency is about 30%. Actually, I am not going to discuss technical aspects, but and also with all these things, still actually in this sector, we have the poverty, child malnutrition, problem of education, many issues are there in agriculture communities. Now, actually, I am dealing with socioeconomics. Now, I am going to just actually all the agriculture experts in different institutions and universities, we have estimated that potential estimate actually paddy may be about 30% in short term, maize 50%, potato 30 to 50, vegetable 30 to 50, sugarcane 20, cinnamon 25. The tea sector actually we are earning huge amount of foreign exchange. Now we are having a shortage of foreign exchange. The tea sector will be affected 50%. That means the yield will be reduced by 50%. And floriculture and foliage, actually, that is actually modern agriculture sector. Totally, we cannot do this using this kind of organic fertilizer only, and also protected agriculture like in protected houses. Actually, now there are trends just to modernization of the sector. Now, these sectors are having very big challenge with these policy means issues. And also, secondly, actually, increasing prices of animal feed and consequent challenges for the providing food means especially protein to the community. And also, that what happiness actually, the good point is the way the trivial, that impact may be very trivial for the means mine exposed crop like nutmeg, cloves, that kind of things. Actually, those are normally not well developed in genetically. Those are normally just close to wild type that in the forest also we can grow. Okay, right now, those are the estimated short-term drop of the crops. And also, because of those, everything actually, we are having potential social impacts. One is actually that first of all, the relevant institution, maybe a Department of Agriculture, that we have the recommendation for all crops in printed and also that in webs, that information set is developed by the people actually for a long period. Now we have to change everything for the new settings. That is one thing, one big problem. And also that varieties we have now actually, now that we were talking about to cultivate using the organic fertilizer only. Now, can we cultivate this kind of improved, that means that genetically changed varieties with organic fertilizer? That is one thing. Actually, there are some varieties in rural areas for paddy and some of the varieties, but those varieties are not readily available to give to everyone. That is another issue actually we are facing. And also, increasing cost of production and low yield, low remuneration. And because of that reason, especially in rural sector, already those are rural people are poor. Now the poverty may be more severe in short term, very short term. I think that although we converted, I don't know whether it is possible or not, although we converted, it takes time to recover the soil for this kind of healthy soil actually for organic cultivation. That is another issue. It takes about 4 or 5 years. And also, loss of employment, especially in, that means is a wet zone, means tea areas. Actually, tea estimated yield will be dropped to 50%. Now, actually, now also many of the factories are running under capacity. Actually, in Mathura, Gol, in many districts, we know that factories are competing with each other to collect their raw material, broadleaves. Now, actually, with the yield drop, big issue is actually many factories will be closed down. And also, because of that, I think many people in rural areas, that unemployment problem will be actually very serious in very short term, maybe within 3 to 4 months if the chemical fertilizer is not there, because the tea plantations are now, that vegetatively grown tea plantations are highly sensitive to fertilizer. People are normally about I think 3 or 4 rounds per year they are applying chemical fertilizer. Otherwise, they cannot harvest. And also, Now, I am not going to discuss in detail. Then, because of the drop of the yields and harvest, ultimately that problem of food security. Now also we are having that problem. And also then we have to actually spend huge amount of money to feed the people. That is actually import bill will be very serious. And again, another problem will come. Can we import the requirement from other countries? Because nowadays actually all the people are facing calamities. That means different actually difficult situation with the COVID. That is another issue actually. And rising prices and people income will be dropped, and also same time the price will go up. Now also we can get
okay, Professor. Yeah, we got your point, and then we are moving to see a very short video because we want to see what is happening in other countries like in Cuba and Israel. So, Chamila, will you be able to play this video right now? I think you saw a very nice video that they were talking about drip irrigation. They were talking about precision agriculture, avoiding food waste, and greenhouse methodologies. So all those are topics related to this subject. Actually, we are talking about right now fertilizer and then pesticides and so on. But still, world is moving towards many advanced developed methods. So I would like to ask from Professor Priyantha Yapa for the second round of question. How do you propose your solutions to improve the existing resources and capabilities, capacities, and also these kind of technical advancements to increase production capabilities? Because we are all talking about quality and efficient output.
Yes.
Professor Priyantha Yapa, it's all about we have to take some examples from many other countries like Israel and Cuba. So how do you propose this thing, Professor?
So actually, under organic farming, there is no restrictions actually for the modern technology. So the only restrictions apply to GM crops, genetically modified crops, and synthetic chemicals. Yes. That's all. So therefore, no problem. So you can modernize organic farming. So that is the type of organic farming that we see. Yeah, that in the video that we watched, and also that is the type of organic farming we always can see in the developed world and in other third world countries as well. So therefore, the organic farming doesn't mean that we are going back. We are going back with the technology. So I think organic farming demands even more technology than the chemical farming, because organic farming is complicated. So it's very complicated. So when it comes to the nutrient supplement, again, it's very difficult. So we have to be very careful, because in organic farming, we deal with 21 elements. So at the moment, 21 elements, there may be more added. So in chemical farming, of course, 3 or 4 elements. So therefore, so in the we have actually misunderstanding that we cannot use hybrid or high yielding crops with organic farming. Yes. So we didn't have the technology about a couple of decades back to feed these high demanding crops to give more yield. Now the thing is, now the technology is available to feed these crops. Therefore, there is no problem dealing with hybrid or high yielding crops under organic farming. So of course, we have to modernize. We have to go for modernization even with organic agriculture. So therefore, we have to use the modern organic agriculture technology. And in the previous presentation, yes, I agree with that. We have a limited land area. So we know that. So much of the land that we have actually abandoned is mainly because of the degradation. So the degradation is mainly due to this wrong type of agriculture. So unsustainable agriculture. So therefore, under organic farming, so we always actually maintain the quality of the soil that we use. So without maintaining the quality of the soil that we use for farming, so we will not be able to continue farming. So of course, so therefore, one of the best solutions to actually get away from the problem of not having enough arable land is also switching from chemical to organic farming, because we know that, so we can't continue chemical farming. So that is why it is called unsustainable. So since we don't have enough land, we have to be very careful to conserve the land, arable land area that we have. So if we implement this program, I'm pretty sure that in the near future, we will be able to go back. It means that reverse this desertification problem in the country. So therefore, I think specifically with the technology, organic farming is not just using compost, cattle manure, poultry litter, green leaves, or not. No. Now the modern organic farming is actually always dealing with the most modern technologies, including the fertilizer technology.
Okay, Professor, I got your point. Are you planning to give some kind of assistance to farmers to put up these greenhouses and kind of implementing new technologies, Professor? How is this situation you explain? Do you have a plan right now, or you are setting up this kind of exercises? Professor Priyantha?
Sorry.
Professor, are you there?
Yes. So actually, so we have, the ministry has actually started getting help, the consultancy from the expert in this area. So I'm not an expert in this area, the protected agriculture, hydroponic agriculture, the soilless farming. So actually, so what we have learned is that actually even the protected agriculture, the greenhouse agriculture is also possible with this chemical-free technology. But the thing is, so within a very short period of time, actually, so we are not in a position to directly convert this protected agriculture systems into organic. So therefore, the ministry has actually has an estimation of the requirement of the inputs to continue with this protected agriculture. So therefore, with the consultation of them, so the ministry has taken some steps actually to to keep a special reservations for them to continue with their business, because there are the experts in this protected agriculture technology. So the people have done some heavy investments. So therefore, not to betray them, so we have a plan actually to import the requirement for them separately. So therefore, they won't have any problems with this, because obviously in the short run, we know that it is almost impossible to convert these protected agriculture systems into organic, fully organic.
Okay, Professor, thank you very much. Now we are moving to Professor Saman Dharmakeerthi. Professor, by looking at the objective, it seems we can see that it is good. How do you propose to have a collaborative effort in terms of overcoming these challenges, what you saw in your last explanation? So do you think that by getting a collaborative effort in all sectors, we can overcome these challenges? Professor Saman?
Yes, thank you. First, at the outset, I would probably sort of make a clarification about some of the cost factors that per unit nitrogen, how much it will cost. So when we do a very quick calculation with the 20% efficiency and 70% efficiency in organic and 20% efficiency in urea, you still have 600 rupees per unit kilogram of nitrogen and 1,700 rupees per kilogram of nitrogen. Just a passing by comment to educate the people in the audience. Anyway, when it comes to the challenges, of course, we all agree that we need to move for high tech. Otherwise, we will not be able to sort of cater to the future demands. Therefore,
Yes.
we need to go for high tech. But unfortunately, what we have at the moment is not that technology. all the farming community in Sri Lanka is lacking at the moment the technology that we have. So if we are go with this technology, these are the repercussions that we are going to see. So
just to disturb you, Professor, just one question. At university level, now in our segments like engineering segments, wherever it is happening something in another part of world, so there are many researchers, research are being conducted to transfer this technical knowledge to Sri Lanka. In agricultural sector, is it not happening in university level to identify these technologies and do some R&D activities? Are they happening, or what's the situation there?
they are happening. They are happening in all places. And for example, recently we started a mega grant from National Research Agriculture, National Research Council funded, where to come up with new eco-friendly technologies to identify different microorganisms who can release phosphorus and fix nitrogen from them, and to sort of give it for paddy cultivation, and to develop pyrolyzers so that we can produce biochar, and then develop biochar-based agricultural products for to protect our environment for eco-friendly agriculture. And there are certain other projects coming in where we sort of try to collaborate with foreign institutes to develop different bioactive compounds, to extract bioactive compounds from some of the resources that we have, and then to introduce. So those aspects are taking place at the moment at university level. You know, the funding for research in Sri Lanka is not ample. I mean, it is very limited, and one of the poorest country in terms of funding for research and innovation. So we have to sort of get collaborative projects get going from other countries as well as from other sources as well. So as a challenge, what we have is, yes, I totally agree with the current technology is not the technology that we are what we want, but unfortunately this is what. And in the foreseeable future, what I cannot say is for a country to convert into an entirely 100% organic, there are huge tasks that we have to do together, right? And so as very correctly pointed out in many places, that we cannot sort of rely with the type of organic material that we have to cater the food production and to supply plant nutrients. And at the same time, we are trying to sort of contaminate our soils, agricultural soils, with some of the low quality organic material that we have, like municipal solid waste, compost, where we have so many aspects. So what we need to do is we need to sort of going for high-tech organic products, like extracting some of these bioactive compounds from organics, and maybe then they can be used to improve the efficiency of our fertilizers, the efficiency of our nutrients that we are applying, either through as organics or as inorganics. So these are the type of research that we need to do. And what I would have sort of highlighted here is we need to develop organic fertilizer production technologies in the country if we are to go for this sort of 100% organic agriculture. And therefore, there should be technologies. Even at the future, foreseeable future, what we can say is we will be trying to produce organic compounds that are from municipal solid waste or other organic source. Maybe in the next 5-6 years at least, we will be producing compost. And at the same time, we have to develop other technologies and identify bioactive compounds and isolate effective microorganisms and come up with some slow release technologies. But at the moment, right at the moment, what we need to do is remove non-biogenic and harmful from our solid waste collections. And we need to have large scale production technologies. Why I say that? At any cost, we need to enrich our carbon pool in the soil, for which we cannot sort of rely on applying minute quantities of carbon or other nutrients. We need to apply large quantities of humic substances to our soil to protect, for which we need to produce humic substances in using the organic residues that we have. And then, as I mentioned, isolate and produce plant growth promoting substances, bioactives. And there was a big sort of debate, at least talk going on in Sri Lanka, that we can use seaweeds. And I think we need to be very extra careful about harvesting our seaweeds in a haphazard way. We need, if we are to sort of use seaweeds to extract bioactive compounds, then we need to grow them separately, and we don't have a capacity to grow them for an entire country. And we don't have humic substances here like leonardite and lignite and stuff like that, but we have some humic substances, but that has to be sort of looked carefully, and what fractions that we can extract. And we can sort of, when we have isolated effective biofertilizers, then we can, we need engineers support, for example, to develop bioreactors to produce them in mass scale, and all the other previous aspects. I think we need to have a collaborative research going on with different sectors of the country. And what we need to also be doing is that organic, a big part is coming from animal husbandry. So at the moment, we don't have a sort of a clear sort of mingle between animal production and the agricultural, how we sort of combine these two industries together to come up with better quality organic materials. And I think whatever the technology or the product that we develop, because of the huge variability in Sri Lanka, we need to test them to identify the correct doses. And that is not what is happening at the moment. In the country, we are sort of blanket recommendations are given for a country as a whole. And whatever the new products that we develop, we need to test them before we go for farmers' fields. And as I can see at the moment.
According to you, Professor Saman, Dharmakeerthi, so very positively, you are talking about biofertilizers, of course, which will be given growth promoters to this agricultural segment. So basically right now, what is happening, these growth promoters are given by artificial fertilizers. So you propose to do so many research in the university level or in maybe in the government segment, so to understand these growth promoters in biofertilizers, right? Is that the message from your side?
Now, let me clarify that. When I say growth promoters, the promoters are different from plant nutrients. Plant nutrients are some components, and promoters will sort of increase the efficiency of the plant nutrients that is being used. So growth promoting substances and bioactives are different set of compounds that we can use to efficiently use our plant nutrient base. So
can't we develop these growth promoters from bio or eco material?
Growth promoters. So now, for example, let's take, if I may explain it, in humic substances, we have humic acid, fulvic acid, and amino acids. And those are sort of growth promoting substances. Once the plants take up, they will promote growth of the plant by better utilizing the plant nutrients like N, P, K, calcium, magnesium, whatever that nutrients that has been taken up. So we need to try to identify, not all substances are growth promoters. We need to identify and separate them out, which is a difficult part. I think that is where engineers probably will play a big role in isolating them.
This is a good message for engineers. I mean, very positive message from you to engineers to work on these areas. because we IESL, they have various areas, even chemical engineers are with us right now join. So there is a big opportunity for us to work on these areas. Thank you very much for giving these ideas. Now I'm going to Professor Ang, talking to Professor Ang. Professor, sorry for keep waiting you there. What solutions do you propose to Sri Lankans by getting some international examples, particularly with respect to the outcome of ongoing R&D activities in your universities or maybe in Malaysia, Indonesia? How do you explain us this situation, Professor Ang?
Thank you, Mr. Tilak. Can I ask for, yes, thank you very much. Now, what I'm going to do is to show you two slides, first of all, and to describe these two slides before I respond more specifically to Mr. Tilak's question. Now, on this first slide, what I'm trying to show you is the full-scale production facility that we have to produce biofertilizers. So that is on the bottom left-hand corner as you look at the screen. In essence, and I suppose here I'm addressing the engineers in the audience, in essence, what you need would be to have people who are familiar with the design and the production of aerobic fermenters. All right, so this is what it is. It's a solid fermenter, and we are producing the biofertilizer in a fermenter like this. So here we are talking in terms of tons of production as we make the biofertilizers. Now, I also now ask you to look at the pictures on the top right-hand corner. Now, this would be the green waste, and we use this to provide the C. If you remember, I talk about CNPK. So the green waste provides the C in that mixture. Then on the top left-hand corner, that is in effect cattle waste. And we use this to provide the N, the P, and the K. Now, what may not be obvious in this whole big mix, because oftentimes when you talk of compost or when you talk about organic fertilizers, we tend to be, our eyes and our minds tend to be distracted by all the green waste and all the NPK sources, the cattle waste, the chicken waste, and so on. And we think that is what it is. That is what biofertilizer is all about. But there is a third component, which is the bottom right-hand corner, and this would be the selected microbes. And I use the word selected in a very purposeful manner. And this is where, by definition, biofertilizers are different from compost. So when we talk biofertilizer, we know which microbes are in there and what they are supposed to be doing for the plants. When we talk compost, we don't necessarily know which microbes are in there, and essentially we are depending on serendipity so that we get the correct microbial population to be inside of the product. So this is a key difference. And I think we all, the audience, myself, and so on, we all have to keep this difference clearly in mind, because once we lose track of this, then there will be certain ramifications, which I will discuss in a little while. Can I ask you to go on to the next slide, please? Now, this slide shows what I call a carrier. Now, this is particularly important when we go towards the use of bioactives, all right? So what do I mean by bioactives? Just to recap what I said earlier on, and to add on to what Professor Saman said a few moments ago. In my mind, bioactives are the microbes, purposeful, selected microbes, right? Not random. Then there are metabolites. And in this category of metabolites, we will have the enzymes, the phytohormones, and the phyto antibiotics, which are supposed to be anti-whatever pathogens that we have identified for a particular crop. Now, to carry this into to the soil, we would need a carrier. And that carrier can, of course, be your carbonaceous material, or sometimes we actually choose to use biochar. Now, for those of you who are familiar with biochar, you will understand that in effect, biochar is somewhat like a low-grade activated carbon. And it has certain characteristics that are similar to activated carbon. One is surface area, and the other one is some degree of sorptive capacity. Not much, but some degree of sorptive capacity. So we used biochar, like I said earlier on, to modify the fabric of the soil, but also to hold the bioactives in a safe manner, such that when the farmers apply these things, they are protected. Now, just to illustrate, one of the metabolites that we particularly want to have, but when we are addressing crops that are infected with, say, fungus, is salicylates or salicylic acid. And I don't know about other colleagues, but I, for one, is allergic to salicylic acid. And you can get dermatitis if you handle that in a careless manner. So when we apply this metabolite onto the biochar and then use the biochar to carry this into the soil, that makes it safer for the farmers to apply. Now, as a side benefit, we have also noticed that when we apply biochar, if you have residual glyphosate in the soil, that is a pesticide that was applied earlier on. If you have residual glyphosate in the soil, then the biochar helps to immobilize the glyphosate such that it doesn't get on to the water or to your food supplies. So what you see on the screen now is biochar. And for this, you would need to have the capability to design and to build your pyrolytic reactors. So if any of you ever decide to come to Singapore when all this COVID-19 thing is over, I can show you full-scale pyrolysis reactors that we use to produce this kind of biochar. Now, the bottom two pictures, you see how we are applying the biochar into the soil, and we are planting the seedling. And on the right-hand side, you see the difference when we do a comparison of crops that are planted in soil with biochar and in soil without biochar. Now, incidentally, I heard early on Professor Yapa talking about protected agriculture. We also use biochar as the substrate to carry the plants and to hold the nutrients that we add to the water, which we then send into the greenhouses to grow the plants. So this is what we have possible when we move from research laboratories out into full-scale production and finally out into the application of the technology and, of course, the products of the technology. Now, I cannot be so presumptuous to say that I understand what is happening in Sri Lanka, so I cannot make specific recommendations to you at this moment in time without studying the situation in Sri Lanka more closely. But perhaps I can share with you some of the things that that have occupied our minds as we went into these things, and you may find some relevance in what I am about to say and share with you, not specific to Sri Lanka, but perhaps more relevant at the markets that we have been addressing. Now, one of the things that we are very conscious of is that when we talk compost, starting from compost, even starting from soil conditioner, right? But particularly when we start from compost and then moving up to biofertilizer and then moving further up to bioactives, there is a distinct possibility that you are dealing with live organisms in the product, right? And if you're importing these materials into the country, then you're also likely to import live organisms into the country, meaning non-indigenous organisms. Now, I do not know what is the sensitivity that, that Sri Lanka would have, but certainly in the markets that I've been operating in to date, there have been sensitivities. So in other words, we were required to really declare what is it that we have inside of the product. And obviously, if you are getting in a compost, then we don't really know. But if you're looking at a biofertilizer or a bioactive product, then we would know what is in there. Now, I would also want to say that there has to be very clear definitions, what we mean by bioactive, what we mean by biofertilizer, compost, and soil conditioner, and so on. And the reason for this is we need to define quality. So just to illustrate, when I talk about bioactive, I am not concerned with the NPK content. In fact, I'm not even concerned with the carbon content. What I'm concerned with is who is in there and what are they producing or what they have produced by way of enzymes, hormones, and antibiotics. So that is bioactive. But when I talk biofertilizer, I need to know who is in there, and I also need to know what is the CNPK. And if I don't have the correct CNPK ratio as required by the farmer, then really I'm not providing the biofertilizer, or at least I'm not providing the correct biofertilizer. Now, we should also be aware that the cost of the materials are vastly different. So the cost structure is bioactive is the apex product. Then you have biofertilizer. Then you have the compost. Then at the bottom of the pyramid, you have the soil conditioner. So the cost is the highest for the bioactive and the lowest for the soil conditioner. And because of this, it becomes totally necessary that the definitions and the standards that are put in place to govern the supply of such materials are very clear, because otherwise you then have the wrong materials being paid with the wrong amount of money. All right. So this is what I have to share with you in terms of the sort of things that have been done. Now, as a sort of my last few words here, what was said about R&D is, I think, very important. I do think that you need in-country R&D, particularly if there is sensitivity over the importation of foreign organisms into the country, all right? If that is the case, then you must have in-country R&D to help the production people, the manufacturers of biofertilizers, identify equivalent microorganisms that would be useful for the production of the bioactives and in turn the biofertilizers. This is critical because if you don't have these equivalent microbes, then you cannot make the equivalent bioactives and biofertilizers. Now, fortunately, we do have recipes for what would be an appropriate mixture of microbes for the targeted application, but you do need to find equivalent indigenous organisms. So this is where I think the R&D is necessary, and it has to be ongoing.
I think, Professor, you explained it very well. So, in fact, I'm moving to the next panel member. So, Professor Abeywickrama will be the last one for the day for this session. Professor, can you briefly propose an action plan to achieve objectives towards the sustainable organic farming system by considering all aspects. That will be the last explanation today with regard to the subject, and then we will move into the question and answer session. So, Professor, it's your time to explain and conclude this session.
Okay, thank you very much. Actually, now that technical aspects were discussed very well. Now, actually, that as a socio-economic point of view, actually, I am not confident about that the proposal, and also that although people are telling that organic fertilizer are being produced, I think we cannot see the proper plan. That is one thing. And the second thing important point is actually that although we can propose some short-term things, actually long-term we cannot rely on. Actually, that in the past also we have experience. Actually, although we have actually take decisions later on, what happened, everything was change, altered. Now that is what I am telling. Okay, anyway, now actually, if you want to go through this kind of change, actually now I think that we need to start somewhere. Okay, but not in this way. That is what I am telling. Now actually that we have to tell some of the short-term things we can do. The complete, really I think that one big issue actually fertilizer recommendation. That is political point actually that we have to stop somewhere. Otherwise, we cannot control and regulate the fertilizer misuse and overuse and the things by the farmer. That is one thing, and also. And quality control regulation is another one. That is also that government sector, and also recommendation also we have revised by the agriculture department based on the particular soil testing and the things. That is, I think everything is discussed by someone also. Now many things are written here. Now I think that important point I have to tell actually that if you have to face this problem, actually if you want to increase the land area, that is one way is there, because the home garden, because home garden land area is very large in the country. That is about 4.5 million. That home gardens are there. That land area we can take into that production process. Then that is one way to expand in the land area. Otherwise, we cannot meet the food demand. And also that point I am highlighting here, that we cannot do everything within 1-2 nights. Actually, that we have to go slowly. Already we have started. We have failed several times, different actually with the farmers, but we have to start somewhere. Okay, but that is not this kind of, that means very quick or sudden changes. Just we can start somewhere. But for the engineers, because we were invited by the engineers. Now actually, what I am just trying to tell that engineers have a big role here to play if you are going to change actually. Now, a big issue actually in the rural areas, big issue is actually technology. Although we cannot transport that fertilizer from Colombo to very rural areas, tea lands in Mondrag or somewhere else. But I think in case of fertilizer, organic fertilizer, we have to produce in the site. That people will need the, what you can say, particular mechanism. But now big issue actually, although they have that today we have the technology, that machines and the things, that is not affordable to poor community. That is one thing actually we have to consider, just that affordable mechanization of composting process, because otherwise we have very long experience. Although people tried, there are problems in crushing the materials, and there are a lot of issues are there now that technical people will talk about. And also that developing for technology for utilizing locally available rock phosphate. Actually, now we have that, although we have that technology can be developed by the engineers, and also that soil testing and nutritional testing devices that should be available everywhere. Otherwise, we cannot test the soil. And also that ICT is a very important area. Actually, that knowledge, although that department is having knowledge, that farmers, that means there's a big gap. I think there may be particular devices and particular mechanism to be developed in future to actually that diffuse that technology to the farmers, and also information. Then again, I think there are several things with the time limit. I am not going to discuss to repellent insect. And now actually not the fertilizer. Agrochemical applications, maybe that insecticide and the things are very serious now. Actually, if you can develop particular mechanism using particular waves that insect repellent techniques, in some countries that is those kind of techniques are available. I think many things, there is a big role to play by the engineers with the collaboration of the agriculture people and the things. I think collaborative efforts are necessary. Otherwise, single group, I think, without joining with the farmers are the very serious, means important stakeholder. And also we should not try, should not do experiments actually by penalizing the poorer sector of the farmers. That is one thing I have to tell. With incorporating all kind of people, engineers, agriculturists, and medical people also, and farmers, we have to have particular collaborative effort. Now we can see the problem because one team cannot solve this issue. Okay, thank you very much for inviting me.
Yeah, I think you explained it very well. Some kind of actions that we can do to achieve this sustainable organic farming system. So with that answer, we are moving to the question and answer session. Actually, we want to invite you to drop your message to the chat box so that we will pick some of the questions and answer. I will ask direct to the panel members to answer those questions. So let me, because by now we have a couple of questions. I mean, 85 questions are there right now. So let me ask first question sent by someone. This is to Professor Yapa. Can we achieve total production of organic fertilizers required for all cropping systems in Sri Lanka within 2 years and stop the import of organic fertilizers? So he's proposing 2-year period. So Professor Yapa, you are there,
Yes.
right?
Yes, I'm there. Yes, of course, our plan was actually to achieve 50%. So 50% organic in Sri Lanka within 4 years. Of course, the 2-year plan is also, 2-year plan is not impossible. But the thing is, we will have to invest. We will have to invest a lot to go for that plan. I think, so the thing is that, especially with this organic farming technology, I think the most important thing that we should not forget is we have all the resources available within the country, the technology, raw materials, everything in our country. So therefore, what we need is actually to so that the experts should flock together to achieve the target. So we need help from all these sections, all the expertise. Okay, so actually you also have a lot to do, especially with the machineries and the artificial intelligence. So many areas that you also can involve in. And yes, within 2 years, so the task is very tough, but the thing is not impossible. So I think so there are some situations that we have achieved the targets even within a very short period of time. I do believe that the 2-year is not an impossible task. So since we do not have to depend on foreign technology and foreign inputs, so we can achieve the target within the country, so by ourselves. Yes.
Okay. So Professor Ang, there is a question for you. How farmers can manage micronutrition deficiencies in organic farming systems? What are the technologies they can use?
So actually, micronutrient deficiency is very common with...
Professor Yapa, this question is for Professor Ang, actually.
Okay.
Sorry.
Sorry.
Yeah, sorry. Extremely very sorry. Yeah.
But of course, Professor Yapa is welcome to answer the question.
Yeah. Together, both of you, because I have to direct this what do you call this person is asking specifically from Professor Ang. So I have to direct the question. Yes. Right. Of course, Professor Yapa is there to answer for any question. Yes. Thank you very much.
All right. Okay, perhaps I can start off and then pass the mic over to Professor Yapa. Now, typically when we are looking at micronutrients and if our biofertilizer had an animal waste input, all right, so the typical animal waste that we use, the first preference would be chicken, then poultry, meaning then the next one would be piggeries, and then cattle. Right. So if we are using animal waste like this, then we have not experienced micronutrient deficiencies. Over to you, Professor Yapa.
Professor Yapa. Hello.
I think he forgot to unmute himself.
Okay. So
yeah, Professor.
yeah,
Yes, yeah, it's okay.
Yeah, there was disturbances in my the connection. Can you repeat the question, please?
No, what the question was actually to Professor. This was how farmers can manage micronutrition deficiencies in organic farming systems.
Yeah.
What are the technologies they can use?
So actually, the micronutrient deficiency is actually it goes with chemical farming. So when it comes to chemical farming, we mainly focus on very limited amount of nutrients, mainly NPK. So therefore, if we continue with chemical farming, yes, there will be a problem with micronutrient deficiencies. But of course, if we use organic additions, so there won't be micronutrient deficiencies, because the micronutrients are the nutrients which are required in minute quantities. So, but organic fertilizer mixtures always actually are rich with all these nutrients. So therefore, micronutrient deficiency is actually not a question for organic farmers. So it is actually it will be an issue with chemical farming. So therefore, the micronutrient deficiency will be solved with organic farming. Yes.
Sure.
So that is, I think that is why the Department of Agriculture mainly advise farmers to use organic fertilizers together with chemical fertilizers. So one of the reasons is to actually to get rid of the deficiency of micronutrients. Yeah.
Okay. Professor Saman, there is a question for you. How do we manage live foreign organisms and foreign fungi coming with imported organic fertilizer? Professor Saman?
I think yes, can you hear me? Yeah, you can hear.
Yes,
right?
yes, Professor. Yes.
I think we have a very good plant protection act, and according to that plant protection act, anybody cannot import any organic material into country with live organisms. So if we are to import, it has to be without organisms, and even that there should be lots of other foreign materials that is coming in to our country, which is not should not be allowed as well. There can be certain antibiotic residues can come in, certain heavy metals can come in, and so we don't need any additional toxins to coming into our soils through this importation part.
Okay. So do we have facilities to identify these things at our laboratories, Professor? Testing facilities?
According to the SLSI has come up with some standards for any material that is coming from as organic fertilizers, and they are developing their other laboratory skills as well. I think it can be done within Sri Lanka.
Can be done. That's a good news. Yes. And then another question is to Professor Abeywickrama. According to him, there are many development officers, I think he's talking about at ground level, are available in the ground level, yes, but cannot see better development in rural agricultural area. So he's asking what kind of a socio-economic aspect is involved with that, Kiela, that he is asking. How do you explain this? Professor Abeywickrama?
But I could not get that point. What is that?
He is questioning, there are many development officers are available in ground level, but there is no it seems according to him, there is no support for rural agricultural area. That is what he's questioning.
Yeah.
How do you look at that situation?
No, that is not regarding actually that this kind of changes, but actually really now that during last, I think, several decades, now our agricultural extension system totally actually collapsed. Now many of the people, they are taking advices not from the agriculture department, this kind of officers, from the fertilizer shops and agrochemical people and tea sector actually, tea factories. Actually this system, all the system has been collapsed. I think that has happened not today actually. I think during last 2-3 decades after actually stopping that what is called that means agriculture extension system. Now later on with the different governments actually they have introduced new organelles, that is this kind of different mechanism to give their supporters, that means jobs for their supporters. Ultimately that system has been collapsed. Now I think I feel that now that although there are people in the rural areas, there are some people actually they don't have an idea also, and they are not interested. That is there. I think with this mechanism, I think that transferring from inorganic to organic, that is not an easy task. That is another issue actually that I am not going to answer. That means what we can do with them. I don't think actually we have to have a good training program. Particular means motivation, and also that we have to change the system. Otherwise, we cannot go beyond this level. That is although that is funny answer, but that is the right thing.
There is another question raised by another person saying that I propose to organize, please invite to organic farming practical experts in Sri Lanka to share their experience with engineers. As per my knowledge, there are some practical organic farmers who are available in this country. So I think Professor Yapa, so this is another aspect that he's opening up. I mean, there are many people who has practiced. We have seen now there are many news articles going on here and there, even in social media, talking about these people who are following this kind of practices. How do you look at this situation, Professor?
So you mean that what I understood the actually the issue is the raised by Professor Abeywickrama is this the farmers switching from chemical to organic thing, yeah. So how can they deal with? How can they deal with? Yes. So the mainly the thing, yeah, we yes, I think we have to we have to go back to mid 1960s in let's say 1965. I think so the similar transformation happened. So even much worse transformation. So even the Sri Lankan scientists have never even seen these synthetic synthetic chemical inputs to agriculture, but suddenly all this technology came to Sri Lanka in 1965. So suddenly, under the name of Green Revolution. So during that time, so we learned how the Department of Agriculture tackled this change with the farmers. So therefore, there is I think the Department of Agriculture mainly, I think so they are the backbone of Sri Lankan agriculture. So especially when it comes to the farmers level, so they have a great role to play with this. So mainly, to train farmers, for example, I can remember, so during a protest in early 2020 in Girandur, farmers were protesting against not giving them enough urea under Gliricidia trees. When I asked them whether they don't use this Gliricidia as a manure, what they said is that, so why should we use Gliricidia? Because the government promised us to give urea. So why should we use Gliricidia? So that is actually not the not the fault of the farmers. So we have to actually we have to change actually the minds of the farmers, So some farmers are addicted to this chemical farming thing. Of course, yes, Professor Abeywickrama is right. So that is actually one of the biggest challenge that the government is going to face. So the government will have to tackle that very carefully. So with the help of the Department of Agriculture and the Agrarian Development. So I think when we have a discussion with the farmers unions in Sri Lanka, then later actually the discussion started with very rude manner with the farmers actually. So they were very aggressive and hostile. So but later when it comes to the later part of the discussion actually, so they completely changed. So then they asked not the chemical fertilizer, they asked good fertilizer for them to actually survive, for them to do their business. So that is actually what we have learned from farmers. The thing, Sri Lankan farmers are very educated. So therefore, we should not underestimate the level of education of Sri Lankan farmers. They are very educated and they can understand anything. They can understand even very complicated scientific things can easily be explained to them. So, but it takes time. We have to use the actually different methods to get them into the track.
Okay, Professor Ang, shall I direct this question to you? There is a concept called low space, no space farming. Please follow that, and then even urban people can grow what they want to eat. Commercial farming not required for everyone and start grow for their consumption. What do you think about this? I mean, he's talking about growing things in our home garden, and then maybe how do you look at that from your perspective?
Well, Mr. Tilaka, from where I'm sitting in at the moment in Singapore, not many of us have the privilege of owning a garden. So that's one of the things that I really admire about Sri Lanka, right? So we live in apartments and so on, and my garden, which is just outside the window, is a little balcony where I have a few pots of plants, and that's about it.
Yeah.
Right? So when we talk about farming in urban areas, by the way, this is something that we actually subscribe to, because when we do farming in the urban area, it reduces the transportation network. So we are producing right at the places where we need the food. So this makes the production of food and the distribution of food much more efficient. Now the difficulty is, if you're looking at an urban area, how are you going to do this? So in the Singapore context, we actually do have what we call urban farming, and we do it at two locations. One is on the rooftop of our apartments. So our apartment buildings typically have flat roofs. So we put our farms on the rooftop. And this would typically be either aeroponics or hydroponics. The other one is what we call vertical farming. And in vertical farming, we either do it in a factory space, we actually build a factory, and the plants are planted in racks in a vertical arrangement. Or we put the racks on the outside of building walls, and we plant it vertically on the wall. So these are the two ways that we do urban farming. Right? So in the rooftop horizontally, or vertically in a factory, or on the walls of large buildings. Now, when we do it in large buildings, we not only control the water supply, we control the nutrients, we control the bioactives, we also control the lighting, and there are sensors in the systems that tells us, for example, whether the plants are happy or not, whether we should switch off the light, because it's not true that we need to turn on the lights all the time. The plants do need to rest for a short while every now and then. So the lights come on and off, and that triggers certain reactions in the plants. And what spectrum of light we use is also important in the production of the various crops that we target. Right? So that is, in a sense, the urban farming that we do. And I suppose this is fairly similar to the protected farming that Professor Yapa and my other colleagues have talked about in the Sri Lanka context.
So I will go to the last question for the day, actually, because we have exceeded the time right now. So what is the possibility? I will direct this question to Professor Yapa. What is the possibility of starting organic fertilizer manufacturing plant in large scale by Sri Lankan entrepreneurs? Is there a certification procedure to follow?
Yes.
Professor Yapa?
Yes, yes, there is the certification procedure to follow. So the Sri Lanka standards, SLSI, has already adopted a separate certification, standards for organic fertilizers. So then, so we have to go with different forms of actually additions: organic fertilizers, solid, liquid, biofertilizers, and again soil conditioners. So then actually, so the thing is that we are new to this area of agriculture now. Now we have just started this, but anyway, yes, the quality control is actually should be the top priority with this. Otherwise, we will not be able to continue with this. So the strict quality control, specifically with organic farming. So as somebody mentioned that, we should not allow any foreign microbes to enter into our country, because we have actually, so we have a very sensitive and one of the best microbial populations in the world, being in the tropics. So we are fortunate to have those microbes. So therefore, we should take every possible steps to stop foreign microbes coming into the country, because that will cause a huge damage. And also, as you said that the Sri Lankan manufacturers are actually encouraged always to go for the production of modern organic fertilizers. So especially now, actually, we already have some the manufacturers in Sri Lanka, especially with the help of Korean government. So there is a fertilizer company in Sri Lanka, and also we have received many the requests from Japan and another request from Taiwan to go for a large-scale production in Sri Lanka. So with the use of the local microbes. So if you want to produce biofertilizers, it should be with local microbes. And yes, and also there are experts in Sri Lanka. So we might need help from other countries as well. So specifically, we have focused some specific technologies, especially the cost-effective technologies during this sudden transformation from Cuba. So we have been advised by the different countries mainly to actually contact Cuba to actually ask help. So because they also have undergone a sudden conversion of this with this chemical to organic in 1990. So I think in 1990 with the sanctions, of course. So therefore, the China, Cuba, yes, maybe Singapore and Taiwan, there are many countries who have come forward to help Sri Lanka. So we are not alone. So there are many other countries, even European countries, have come forward to help Sri Lanka to go ahead with this program. So therefore, there won't be much problems. But in the short run, so we will have to go through some hardships. But in the long run, so these investments will be worthwhile.
I think with that, we are going to conclude the session because we have designed earlier this program only for 2 hours. I hope 2 hours is not sufficient, but I hope this little effort would be a support to achieve objectives of this agricultural sector. So with that, I would like to thank all our resource panel, especially Professor Priyantha Yapa, from Faculty of Agriculture Science, Sabaragamuwa University, and member of Residential Task Force, and also Professor Saman Dharmakeerthi, Faculty of Agriculture, University of Peradeniya, and also Professor Wun Jern from Singapore, Nanyang University. Professor, thank you very much, especially joining with us to support Sri Lankans in this special moment. Your support is very much appreciated, and we hope you will support continuously to Sri Lankan people in this manner. Professor L.M. Abeywickrama, Faculty of Agriculture, University of Ruhuna. All of these professors, they are very knowledgeable in the subject, and they were explaining very much about their ideas and way forward plan in this regard. At the same time, I should give a special thank to Professor Samin Jinadasa and also Dr. Pradeep Kajanayaka, who supported me organizing this event and supported me and the organizing committee to organize this event. Actually, without them, we could not have arranged this event successfully like this. And may I also thank you, Chamila, who was behind with me to arrange all those facilities, who is the media manager of IESL. And finally, I would thank Professor Ranjit Disanayaka, the chairman of Media and Publication, Library and Publication Committee of IESL, and also rest of the team who supported us, especially giving this opportunity to conduct this program. Thank you very much. And at the same time, IESL, thank you very much for giving us this opportunity. Let's meet another day with another very good topic. Thank you very much.